Welcome back, everyone. We have reached a pivotal moment in our preparation roadmap. In our previous session, we crashed the gate. We used the chemical equivalent of a sledgehammer to clear out the massive, rowdy crowd of proteins. But let's be honest with ourselves. Simply clearing the stadium isn't enough. Even when the stands are empty, the VIP room might still be full of imposters, lipids, salts, and stubborn matrix components, loud enough to kill your signal. This is where we move from the sledgehammer to the scalpel. Solid phase extraction, or SPE, isn't just another filter. It is an elite bouncer. Today we learn the art of strategic purification, turning shaky signals into pristine, publication-ready data. Have you ever felt that sinking feeling when your signal remains shaky even after meticulous protein precipitation? That's because clean air is not the same as pure. Leftover lipids and salts are the imposters lurking in your sample, waiting to suppress your analytes. Think of your SPE column as an elite security detail. It doesn't just let everyone through, it performs a background check on every molecule. An operator sees a plastic tube, a specialist sees a tactical environment. This mindset shift is what separates a successful discovery from a noisy failure. Let's look at the logic that governs this bouncer's decisions. To master the selective filter, you must stop seeing SPE as manual steps and start seeing it as a three-act play. Act 1, the selective handshake, binding. Act 2, the ruthless purge, washing. Act 3, the golden release, elution. And finally, Act 4, enrichment, the signal volume knob. Over the next few slides, we deep dive into each. Pay close attention to the chemistry, because if you miss the logic in one act, the entire play falls apart. Let's start with the handshake. Act 1 is all about the selective handshake. After conditioning our bouncer, we load the sample. If you have done your homework, your gold analytes will perform a specific chemical handshake with the solid bed. They recognize each other and stick. Meanwhile, the bulk of the junk falls straight through. A technician hopes they stick. A specialist knows they will because they've architected the solubility environment. You've matched the polarity or charge to the functional groups on the sorbent's surface. If the handshake is weak, your analytes are already in the waste bin before you've even started. Welcome to Act 2, the ruthless purge. This step requires cold, calculating logic. If your wash is too gentle, your sample remains dirty. If it's too harsh, your gold ends up in the waste bin. We use a wash solvent just strong enough to kick out lipids and salts, but not strong enough to break the handshake with our analytes. This is surgical precision. A technician rushes this step to save time. A specialist meticulously tunes the solvent percentage to maximize the signal-to-noise ratio. Audit your waste vial during troubleshooting. If you see analytes there, your purge was too ruthless. Finally, we reach Act 3, elution. The room is clean, and now it's time to escort the VIPs to the detector. We bring in a stronger negotiator, a solvent the analytes love even more than the sorbent. This solvent breaks the handshake and pulls the analytes into a tiny, pristine volume of liquid. Actually, here is where 90% of your publication-ready data is born. You aren't just cleaning the sample, you are delivering the concentrated truth. We use the minimum solvent necessary because every drop should be saturated with your target signal. You've moved from chaotic matrix to refined solution. You cannot hire the same bouncer for every party. If your analytes are hydrophobic, greasy molecules, you deploy the reverse phase, C18 bouncer. He loves fats. But if your analytes are charged, you need the ion exchange team, MCX for bases or MAX for acids. These use electrostatic magnets to catch specific molecules while letting everything else slide. A common mistake is just grabbing standard columns. A specialist looks at the pKa and log P and designs a bouncer tailor-made for that VIP. By choosing the right chemistry, you ensure a 100% success rate for your handshake. Beyond cleanup, SPE has a strategic superpower, enrichment. Imagine trace pharmaceuticals in 10 milliliters of pond water. You cannot inject 10 milliliters into your mass spectrometer. It would drown the signal. But with SPE, you can bind those analytes from the entire 10 milliliters onto a small bed, then elute them into just 100 microliters. You've achieved a 100-fold concentration boost. You've amplified the voice of your analyte. In clinical and environmental labs, this enrichment is often the only way to see the truth. This turns OK data into data that gets published in high-impact journals. Even the best bouncer can get overwhelmed if 1,000 people rush at once. In SPE, we call this breakthrough. It's why technicians see low recovery. Breakthrough happens when you load too much sample, or the flow is too fast. Your analytes don't have residence time to handshake, so they slip into the waste bin. A technician blames the mass spectrometer. But a pro performs a waste audit. They check the loading waste and wash waste. If your analytes are there, your bouncer was too busy, or your chemistry was mismatched. Slow down. Give the molecules time to talk. We've moved beyond bulk removal and into surgical precision. You've mastered the 3-act play. You know how to choose your bouncer and how to turn a dilute sample into a high-intensity signal through enrichment. If you carry only one thought back to your lab bench, let it be this mantra. Great mass spec data isn't made in the vacuum, it's made in the SPE column. The instrument can only measure what you give it. Give it pristine, concentrated samples, and it will reward you with truth. You are now an architect of the molecular environment. You have mastered the solid filter for liquid samples. But what if the gold is invisible? What if it's floating in the air as a volatile aroma? To catch these molecules without using a single drop of solvent, we need something even more elegant than an SPE cartridge. We need a way to take an invisible sip of the headspace. Join me in our next unit, Module 2-6, the invisible sip, where we utilize solid phase microextraction, SPME, to capture these volatile chemical fingerprints directly from the air. We've cleared the debris. Now let's learn how to catch a ghost. I'll see you in the next module.